Hi, everyone. As an engineering company, maybe this talk is going to be a bit more technical, but still, I'm going to concentrate mostly on the challenges we had as a developer company. We have been building a lot of app for Ledger over the years. And to us, user experience, in our particular case, meant more developer experience. It was a kind of like how we could develop apps in an efficient way and how we could improve our processes in certain processes that could like allow us to get like better quality, improve like the speed, and release more apps that we were like proud of. So I'm going to discuss a bit the evolution in the last 3 years, and after that, discuss a bit more like what we are planning for next year. So, I mean, in general, building Ledger apps represents a significant part of our time, of the time our company puts. And we develop a really large amount of Ledger apps. So we have like at least 25 apps for many top coins, and on top of that, we have like a lot of apps that have been like fork or that they depend on our development. So for example, we have done things like for Polkadot, Filecoin, Kusama, Cosmos, Tesos, Internet Computer, and many others. And there are like a few others that depend on our source code, and they have like done certain modifications. So in a way, we have a really large amount of dependencies and code that is shared between them. Over time, this has been improving, but this means that we also have a very large similar code base that is evolving not at the same pace. So obviously, we wanted to kind of improve our processes, and the main question for us was, how could we be faster and more efficient? And the idea is that we wanted to develop our, to improve our development cycles. To do that, we want to have like quick feedback from how we are doing and how the chain is working, and actually we want to concentrate more on the problem rather than on the technology. And in that sense, we try to avoid as much as possible like interacting with the hardware, because that increases the time it takes for us to develop. And to decouple functionality, and this is a typical problem in embedded development where, I mean, in general, and obviously the case of Ledger is different, because in general, when you do embedded development, you have access to hardware debuggers, you have access to a lot of tooling that goes around the device. But in our case, because Ledger is a secure device, obviously we don't have that. So we had to kind of find some kind of like workaround. And a core point for us was to decouple the functionality that is chain related to what was like Ledger specifically related, and work more on the PC side rather than with the hardware. And obviously that means that we also wanted to have like extensive testing and release and work, not completely like TDD, like test during development, but we wanted to go in that direction. And that's typically something that don't happen so much in embedded development. So these are kind of like the main things we wanted to attack like in the last few years. And for us, like as I described, like aspects like architecture or tooling were like important, but at the same time, team culture is super critical, because when people get frustrated, quality also goes down. So these are kind of the challenges we were like kind of like to address. And obviously, what this means, it means that there is less frustration, abstractions like help a lot, and then you can pay more attention on how the chain ABC works, and not to get like too much into Ledger-specific problems, because we already know like how Ledger works, but we need to speed things up. So this is basically what we try to do. Obviously, since we started to work, Ledger also improved their processes a lot. I mean, the situation is not the same today, and we have been like kind of like evolving together, and it was like a super good experience. But at the beginning, the whole ecosystem, like blockchain in general, was more immature, and this has been like kind of a constant evolution. So, I mean, the answer to all these things, basically for us, was like work on tooling, reproducibility, look at how we can improve the dependency management. So when an app has like 3 forks and it has been modified like here and there, we could like address all these issues like rapidly and efficiently. And also massive amount of testing. Maybe a bit unusual, like compared to even other apps that we were not working with. But we concentrated really a lot on testing at every level. Even like more advanced techniques like static analysis or fuzzing, we were like doing that initially internally. Later we started to open source all the tooling that we were using. But this was like kind of something that we were like kind of paying a lot of attention to. And in certain ways, something that maybe it's my opinion here, but in a way, when you have these processes, like peer review or pull request review, it's super important. But when you go into opinionated discussions, that delays a lot. So we put a lot of emphasis on linting, which is automated checks for your code style, and then you don't argue between like people, you argue with the bot, and that's it. So, I mean, the first process like that we addressed at the beginning, this was like 2019, was like how to build for Ledger. Ledger is very different to a normal computer. It requires something called cross-compiling, that is, you don't use the same tools. You need to create like different things. You also had to use a tooling that was not super standard because it was like a certain specific version. So at the very beginning, there were like multiple ways of working. You could like put everything in your computer, but it was your computer, and then your peer didn't have the same thing. Everyone was using virtual machines. They were like small. There were like users that had trouble with like drivers. I'm talking not about like final users. I'm talking about like developers in our team. So that just to. But then we started to work on Dockerizing the whole toolchain and also moving that into continuous integration, so we didn't have to do that. There were no more reproducibility issues. Everything was like kind of easy to do. And then what I described before, we divided completely the code for the chain from the code that was specific, like user interface or dealing with cryptography, in such a way that we didn't have to pay so much attention to that. We were like kind of looking at, okay, how this blockchain works. And that was kind of like the concentration. We spent like seriously, I don't know, 5–10% of the time working on the Ledger app itself. We were like really concentrating on the chain. And that was already very challenging because in a way, when you think of like 25 chains and constant innovation, it's not that you start like kind of like copying and doing. It's every chain is different, and you have to learn a lot about that. So that gave us more time to concentrate on the important parts. So the other thing that I describe is this idea of like doing unit testing. Typically in embedded systems, unit testing is a bit uncommon because you cannot really test in the hardware itself. And a lot of people are very used to manual testing, like get the device, clicky, until you get to the point where, okay, things fail or it passes, but you don't really know the kind of like adequate coverage that you have, and you cannot really do like a lot of regression testing, like check that you didn't break everything. Let's say you had like a set of 20 tests, and if you get like manual people to test that 20 times, it's kind of a problem. So the main thing is like we want it to work locally. The device, we don't touch it really until mostly the end of it. And for us, it was super important. I will describe this a bit later, but it was super important that we had a lot of test cases. So whenever we start the project, we take the chain and we concentrate on generating like a large amount of possible transactions for that chain. And that's our test. And then we just work locally, getting that set of like, I don't know, 1,000 transactions to validate and produce the right result in the console, like just normal PC. We don't touch the device. We just like work in that cycle until things start to make sense. These test cases, also, we can cooperate directly with the chain, describing like, okay, this is what the device will show in the future. So we have like very, very close normal cycles of development. And then we have a point where these test cases, we can like send them in two directions. We send them to our kind of like unit test that is like PC code, or we can just like send that to an emulator. And the emulator, I'm going to discuss that a bit later, but it has been a kind of like the emulator we use is kind of a wrapper on an emulator that Ledger launched in 2019, and it really helped us a lot. Before that, we were like kind of mocking certain areas of the application, but it was not the same. So once Ledger launched Speculous, that was like super, super useful. What we had to do is we typically, in this diagram that we have here, we typically have two deliverables. I mean, we normally don't do just the Ledger app. We do the Ledger app and an NPM package or some other language. It could be like Rust or Go or any language. But that's the library that the client will use to connect to the Ledger app. And it communicates with the app, and we abstract away all the communication. So in that way, when we deliver an app, we also deliver something that will work with Live, or it will work with any web pages, or I mean, we just like isolate the problem from knowing that they are talking to a hardware device. And the main thing is we wanted to ensure that the whole integration worked. So while the emulator was emulating the device, we also wanted to kind of like provide some kind of environment that was like very similar to, or like at least a very minimal browser. So we wanted, in general, we do that with JavaScript. And the idea is that you could like say, OK, this is my unit test or integration test that is like similar to what you would have in a website. Load this package and talk to that device. The device is emulator or physical. So at some point when we get kind of into some situation that the emulator doesn't behave like the device, we could just toggle and go to a physical device. But in general, that meant that we were like testing in continuous integration as if the browser was talking to the device, signing, doing the whole process, taking snapshots, doing regression testing continuously. So every pull request or every change that is made, we do that check. Obviously, we had some challenges, and these are challenges that we could say are not even in Speculous, are like even in a deeper layer that is called Qemu, where there are things like, for example, this maybe is too technical, but I'm happy to go through that, or maybe we can discuss that later, or me or someone in the team. But there are things like, for example, called unaligned access, where even if the emulator does everything OK, the physical device will crash in that case. And so, I mean, if you test in the device, you will recognize that, but in the emulator, it will not happen. There are things like linking issues, or sometimes the emulator doesn't have a correct assessment of how much memory you need when you make an API call, so it will not work in the device, but it will work in the other case. And we had that thing. So, I mean, this is mostly like a joke. At some point, and I'm saying this with a blink, I was like thinking of writing a letter to St. Nicholas, so he could like give us a kind of ledger. I mean, we tried to do some experience with the servo, but we actually wanted a ledger that had like kind of pins that we could just like directly click from outside. So it was like kind of a super complex emulator where we could really test in the physical device. I mean, we did this experiment. We are not using this now, but maybe Nicholas can hear me, and we get this. And then we did other things, like what I described, continuous integration. We do fuzzing. We do releases, because sometimes a problem that we see during our development process is that projects do not want to wait until they get the app, the final app published. They need to start like developing their websites or their web wallets with some very small app that is unfinished. So we have to do like a kind of internal releases that we have like a kind of a very simple installer that obviously we put like a big do not use in front of the app. But teams then can get like an unfinished app after the first milestone, and they can start integrating until at the same time we continue the development and we put all the features. That's when we send to Ledger. And then we typically have done for many of these top projects also third-party audits before like Ledger audit, so we ensure like certain level of quality there. So this is what we are like today. And this is obviously, we want to keep like raising the bar and improving our processes, and also it helps for the team because we can kind of maintain and improve the quality of what we deliver. So, I mean, what we're planning for next year is first, we want to address dependency management, because that's one of the biggest issues we have today. When we have like 30 apps and they all are in different repositories, and then we find like something that we would like to improve, or I don't know, we want like to improve formatting in something, or let's say worst case, I mean typically that's not the case, but some fix that we need to make. And we know that the impact, when we assess the bug that we find, applies to, I don't know, 10 apps. C, that's the language we're using in most of the app today, is not good. I mean, it doesn't do dependency management correctly. You need to start like doing copy-paste, checking everything. Like, it's very complicated. And the thing is that also, sometimes because apps are evolving differently, sometimes the fix is not the same, so we have to start doing like hot fixing, which is even worse. So we wanted to kind of improve dependency management. The other thing is we want to start like thinking how can we like shorten the cycles even with emulation. So we're working on something that I always play like very quickly, or like working more on the console side. And then what we saw this morning about like some NFTs or applications in Ethereum where you want to see the information of the contract that you're signing. These plugins, we're kind of also entering into plugins and starting to work on plugins. And we are planning to work a bit on some kind of like base library that we use for that. I mean, basically the main concept is reuse, dependency management, and again, reusing our cycles. So obviously, the main point, or at least what we see as a solution on our side, is start to moving our development towards Rust. Basically, we have already used Rust in production in some apps. At the moment, we did like Zcash for shielded transactions. We work mostly all the cryptography in Rust. For Polkadot Kusama, there is some cryptography done also in Rust. And there is an app for Blockstack where most of the core functionality that we have today is already in Rust. So it's not that we are like kind of like thinking of doing something that is untested. We have been doing this progressively. For Tesos, the application is going to be almost like 99% Rust. The main thing is that the SDK that Ledger releases today is, I mean, it has all the kind of like APIs in C because that's how the ecosystem works. So instead of like going like too far and just migrating everything to Rust, it was like a bit of risk and also kind of like pushing responsibilities to Ledger, so they also need to maintain two SDKs and everything. So for us, it made most sense to just make a very, very minimal shell, kind of like a very, very minimal layer that connects C with Rust. We still use the same tooling. Ledger doesn't need to adjust anything, but most of our core application is written in Rust. The advantages is Rust has something really nice for dependency management. So that means that we can like publish packages that do, for example, things like user interface or like the important parts that we repeat for cryptography or some aspects like formatting or parsing, and then we can reuse that. And then if we find changes or we want to make like improvements, then we can just like use like adequate versioning, semantic versioning, and say, okay, this is a backwards compatible change. We just like push it, and then the upgrades happen like very quickly. This idea of hybrid applications that I write about that there is this idea that, okay, we don't want to go like 100% Rust because of these issues. But it's not perfect. I mean, Rust still has its problems. Rust is really good in normal, large devices, but when you go into very, very, very small devices, even if the change is marginal for big ones, here is really relevant. So we had like sometimes problems with binary sizes. Now with like the new models, this is not going to be a problem, but we still need to maintain the old ones. And then apps are getting fat. And RAM consumption is also kind of like a problem. I mean, it consumes more memory, and it also results in bigger apps. There is something called PIC. This is much more technical, but today Rust doesn't do that properly. We've done like quite a bit of experimentation. We don't want to patch compilers, so at the moment we found some kind of like balance that give us like the advantages of Rust. We are having to solve that problem fully. But it's something that we will be working on a lot. And then, yeah, there is this thing of like SDK upgrades that for us it could be more work, but it's good. So we don't mind too much. In the worst case, I mean, we need to maintain these things anyway. So I mean, it will mean like an additional work on our side to every time that there is a new SDK, we need to catch up a bit. But we expect that this is going to be kind of in the order of like a couple of days. So with respect to plugins, we are already initially thinking of like working the Ethereum plugins in Rust. So all these apps that, or all these kind of like applications that are based on smart contracts that run on the Ethereum app, we will kind of start generating that, but not in the standard plugin structure, but using the same. I mean, in the end, we can provide the same kind of way of connecting, so that should not be a problem. And we are trying to use, in order to solve the problems like apps getting large, we are trying to use the same model for other chains. So probably the next one that we are going to be kind of using this plugin structure is Cosmos or substrate-based applications. And the last thing, and this is more a bit promising, a bit more experimental, because there are like still some open points, but we think that using the ABI for smart contracts, we can just automatically generate these plugins. So we will try to get some kind of like additional tooling, so it should be like a lot faster. Once you know the ABI, you know what the smart contract is, and a bit of like manual adjustment for like, for example, property names or types or formatting, then you could just generate the Rust code for the plugin. So we think that's going to go like pretty fast and well. And then there is this thing of like console apps where sometimes when we want to run in emulation, it takes, I mean, most of our unit tests work really at the unit level, but we wanted to have something that felt like speculous CEMU, but we wanted to do that directly in the console, like really quick, not even going through all these other emulation layers. So we are trying to mock up a bit this. That's something nice of Rust. We can have like the different implementations for kind of the same crate. So that's something that we are also kind of improving, and we think that this is going to speed up our cycles too. I mean, obviously, the additional advantage, and that's more for the community, is that what we do in Rust is published as a crate. So obviously, those crates can be reused in other projects. So instead of, like, for example, having a fork where someone takes a repository and makes a copy and data is difficult to maintain, the app is going to be minimal, but there will be like packages that could be reused and taken from those apps. So that simplifies a lot the development process. So that's kind of like a very quick history in the last like 3 or 4 years, and how we are like moving from what we are doing today and what we are going to do next year. And obviously it was like a bit technical, so I'm happy to answer like technical questions now or later, or someone from my team. But yep, thank you very much. Yep. Thank you very much. Go ahead.
I just was thinking maybe somebody else will have questions.
Okay.
Yeah. I think that really wow effect, it will be create the mobile phone with the ledger inside. So we already have 2 buttons like volume on the each mobile phone. You just implement your chip inside of the mobile phone. I don't know, maybe it will be ledger phone. Maybe you can speak with some people who produce phones, for example, in France, and make this wow effect. Like you buy the telephone with implemented inside ledger. And it will be something like a secure phone, and like Google or other corporations always have this pre-installed stuff, have the Ledger Live pre-installed and everything to connect, MetaMask pre-installed. I don't think that it's really hard if you already have it's on the something like a USB stick, just implement it to the mobile phone, and I will buy such thing.
I mean, I can have my opinions about that, but to be fair, I mean, we're more like a software company, so we're not really into hardware manufacturing. I mean, I suppose that the evolution, yeah, it might go in kind of like improving the interface more and more. But I don't think I'm the person that can answer your specific question. I mean, we are more like at the moment like a software company in the blockchain space rather than someone that manufactures hardware. But yeah, that sounds interesting. Yep. Thank you very much.